So good morning for whomever morning it is for. I know it is for you, Peyton. Hi, Kareem. Happy to have you here with us. I know it's webinar season for about 6 months now. So we're happy to have you on with us today. Hopefully, we have some interesting content laid out. If you're interested in how to secure Terraform in a developer-centric way, I think you're at the right place. We're going to walk through our mutual relationships between two community and ecosystem partnerships. Obviously, if you're here, you're probably familiar with Terraform. I'll give you a very brief background about us, about Bridgecrew. We're a fairly young startup, about 18 months in the works. Started out in the beginning of 2019 with a goal to bring more cloud security responsibility and tooling to the hands of infrastructure developers. Ourselves coming from infrastructure and cloud native development background, we just found huge opportunities to improve overall security posture in small and large organizations alike by implementing some of the best practices and processes that were actually developed in the biggest cloud native companies in the world. They're thankfully distributing that knowledge through open source technology, community projects, and others. And essentially what we try to do is take that learning and essentially coordinate that into a single unified platform where cloud native infrastructure centric security can happen. Companies, almost 30 employees so far, raised $18 million recently in total, and backed by the fabulous Battery Ventures. And what's I think the nicest thing about this space is that everyone can really try it out. We'll talk a little bit about the platform and its core values, but let's maybe start with a little bit about what we do. So essentially, Bridgecrew is an ecosystem platform. It connects to the cloud infrastructure ecosystem. One side of the house is essentially dedicated to cloud native configuration. So think everything that operates through a cloud operator's or cloud provider's API. So if you're using something like the Amazon Web Services console, or you program using the AWS SDK, or preferably you use a declarative programming language, universal one like Terraform that essentially lets you write any cloud resources using a unified language. Bridgecrew is a place where those configurations essentially get crunched up into a single policy engine and enable DevOps and security practitioners to apply unified policies wherever configuration happens. The other side of the house is essentially configuration frameworks. So we support most cloud native configuration frameworks with a strong emphasis on the biggest projects probably to date, which are Terraform and Kubernetes. And our challenge and the main problem we're trying to solve is how to bridge the gap between the infrastructure that gets planned and programmed in infrastructure as code and make it work nicely with the essentially the software that gets eventually run and runs our web applications in a public cloud. We do this with a set of technologies that essentially allow us to build a unified data model that's built on those two sides of the house. And essentially what we try to do is to translate this mesh of configurations that can come in various shapes and sizes into a unified stream of conscience and essentially bring a unified logic of community tooling, best practices that are reliant mostly on industry benchmarks, and on top of that, the requirements of compliance and controls. The main use case today our users are using Bridgecrew to solve is essentially to fix misconfigurations as fast as they occur. And without going too much into the weeds of it, instead of chasing down potential misconfigurations after they got deployed in production, probably giving us a headache since they're already in the works, we try to help our users to find those as early as a pull request or as late as as a build process, or essentially even in production, and to equip developers with boxed fixes. So give them the code that essentially describes the optimal performance of a configuration, or essentially bring in code that translate into conformance in terms of requirements, especially around industry-specific requirements. And the strongest emphasis is on automation, not just because it saves time, but essentially because a lot of the manual work associated to remediating an incident after the fact ties back down to the fact that most of the manual tedious one-off tasks that we do with scripts can be probably solved with a conformed automation process. So how does the platform work? Really quickly, we look at one side, which is infrastructure as code, look at its entire life cycle from the point it gets committed into a feature or side branch, all the way to the point where it gets merged into a main branch or a conformed branch. We can follow throughout a CI or CD process and essentially continuously check if our policy and best standards are kept throughout the deployment cycle. If not, essentially produce the output that enables either the DevOps or platform engineer to find the root cause and to analyze it. And essentially, where possible, to invoke an automation that can help resolve or remediate the issue. If it's a code error, essentially throw back a code fix all the way down to a developer that had made that bad error. Or if it's already in runtime, we use an array of serverless functions that can go into somewhere like AWS and revert the configuration to the required or to the good known state. And in that way, we try to keep both sides balanced, where misconfigurations don't get deployed into our runtime code, and errors are not inserted as part of our infrastructure as code. We found that using this type of automation, we usually decrease the number of incidents that could potentially arise using open source or publicly available modules by as far as 90%. So taking some of that shifting left and automation ideology and trying to insert it into very practical terms as part of an existing development process. And we can talk a little bit more about that as we move forward. Kareem, to you.
Thank you. I love automating secure code. It's honestly, there's so much to lose by having things misconfigured, EC2 instances that misbehave, cost control that doesn't catch that you have misconfigurations. It happens. So hello, my name is Kareem Satirli. I'm a senior developer advocate at HashiCorp. We focus on solving development and operations and security challenges actually in IT infrastructure. So your company, your project, your business can focus on what's critical to you. As a company, we're, I think, just a bit above 1,000 people strong right now. We currently have 6 main products: Terraform, our infrastructure as code application; Vault, our secrets management solution; Console, our service mesh and distributed key value store; Nomad, which is our job orchestrator; and then going a little bit back in time, Packer for building your images for your computing needs, Docker images, EC2 images, so EMIs, and of course, Vagrant, which probably everyone has used at one point in their career. So, of course, we also have enterprise and hosted options. We'll talk about that a little bit later, but in essence, we're here to meet you where you need us most. So let me talk a little bit about Terraform before we get in the weeds of it. So Terraform is an infrastructure as code application, which enables operators or developers, no matter how you identify, DevOps engineer, it's all good, to deploy code in a predictable way. So you start out by codifying your infrastructure, and because it's code, you can commit it, you can roll back, you can roll forward, can have releases, collaborate with your team. It's all there, right? And Terraform does that through a unified language. As Guy mentioned, we use something called HashiCorp configuration language. If you've ever written nginx config, might look a little bit familiar. It's not an identical copy, but it's easy to get started. And that's where you go from. And so once you've written your code, we have separate plan and apply steps. So you tell Terraform what you want, you plan an execution, and Terraform will tell you, this is what I'm going to do. I'm going to start an EC2 instance, create a firewall for you, security group, a database, maybe I'll remove something. And then when you've gone through that and you're like, okay with all the changes, you apply it, and that's there. And because it's code, it's reproducible. Quickly need to spin up a different environment with 20 of those identical instances? Not a problem. Change a number, you're good. Differences between those environments disappear if you set up your code correctly. But if you've ever worked in engineering, you know that writing the code is the hardest part. So we have tooling around that makes life simpler in terms of building it. And as we're noticing that many more people, many more companies even, accelerate their digital transformation, going from old school data centers, racking and stacking, to just having everything in the cloud, we introduced Terraform Cloud, which is our solution to make collaboration around Terraform a little bit simpler, a little bit more straightforward. So we help you with shared state. We make sure everything is secure on that side. You don't have to worry about clashes between operators trying to deploy changes at the same time. And you can work with your team and iterate on your infrastructure, build up, build out, scale out, whatever you need. We're here to help with that. From a technical perspective, and this is the stuff that I'm more excited about, we have full support for GitOps. So anything you commit runs through. I know Guy's going to show a little bit of that later on. And for the integration side, we have a full API where you can retrieve the information you need, like our IP ranges, so you can automate your security tooling around that, and then make sure that, let's say, your Jira ticket gets updated when a deployment has happened. And so, enough theoretical knowledge. Let's have a quick look at some code. So what you see now, these 5 lines, that's a basic Terraform resource. In this case, we're starting an EC2 instance with an instance type of T3 large. And we're starting this in US West 1, which I believe is Los Angeles, with an AMI ID, which we retrieve through a variable. Even if you've never written Terraform code before, this should make sense. And that's the goal, a language that is easy to get into, because that means you'll use it. Things that are hard don't get love, and then people don't use it. So if you were to write this code, Terraform plan, like we said before, really quick, you see that Terraform will tell you what it's going to do and saves this plan. So if you're ready and this looks good, and I think it does, we can apply it. And if you give it a few seconds, 12 in our case, you've got a new EC2 instance. Green text at the bottom is always nice because that means stuff worked out. And with that, I think it's back to you.
Beautiful, great. Thank you so much. So I think one of the things that Terraform makes super easy in terms of even conceptualizing is so many of our day-to-day security and compliance challenges eventually get wrapped in this continuous and laborious process of inserting change. This could be the first time you provision a new infrastructure resource, which is always something that's that could be interesting in the sense that maybe it's a service that was never used in this in the context of my environment, and what's the risk or what are the unknowns that it introduces into into my potential production flow, and even a day-to-day change. So essentially, we ideally want our applications to scale out automatically or to roll out features automatically, but we know that's not the case. Especially for rapid or fast-moving development companies, and obviously cloud native is a set of technologies that enables you to move very, very fast. You understand that everything ties back into the underlying infrastructure that runs it, and the elasticity that cloud providers and declarative infrastructure as code will enable us is to try to bring some sense into this wild array, this wild canvas. So we put some very high-level tasks here that we've seen our more advanced users try to tackle head-on with infrastructure as code. And I think some of this will make a lot of sense. Things like having reproducible workflows for injecting new code as part of a build process. It makes tons of sense to have that as part of a continuous and repetitive deployment process. But what an amazing benefit for change tracking. Suddenly with a platform like Terraform Cloud, I can obviously start to version control every change to infrastructure, be able to attribute it to a single resource owner, and start to define accountability, not only when the error happens in midnight as part of a running workflow, but far earlier in the process. And this is where a process like code analysis, in this case static code analysis, could make more and more sense, because if we're managing configurations solely using code, maybe we can apply logics the same way as we do when we do things like unit tests or stress tests. So code analysis to verify the changes that happen to infrastructure suddenly starts to make a lot more sense in this context. And actually, a lot of the motivation for us to come and to build on Terraform internally for our product and also for our users has been, since we're seeing this motion of more and more configuration moving from manual one-off tasks into reproducible infrastructure as code. In the commit process, it's staggering how much when you look at team collaboration and how teams have been able to work each other on scaling infrastructure, using infrastructure as code has so many benefits. So think about a world where we couldn't have been able to trace potentially where dependencies came from and where images were drawn up from. Imagine a world where we wouldn't know exactly what processes had backup defined by default and which didn't. Suddenly, as part of our source control management, we can start to regulate processes, and Kareem justifully mentioned GitOps in that sense. So suddenly we can insert checks as part of our commit process using code analysis to vet that each and every change goes through these sets of preconditions to ensure that we won't get vulnerable images or vulnerable dependencies into our code. When we look at things like CI and CD systems, we suddenly have a huge benefit for traceability of assets. So using things like Terraform state files, I can start to attach the potential resource that we get eventually deploy and do things like cost estimations and blast radius to identify how my fleet of resources is going to look like when I push it into production. Compliance becomes a team effort because it's no longer the sole problem of a compliance officer that needs to evaluate what essentially got deployed on the front end, but there's this chain of liability and chain of accountability that we can start to tie back to a specific build or a specific code committer. And when we look at the essential day-to-day operations, there's these new use cases that we can suddenly approach from an entirely different angle. Things like ensuring IAM policies are adhering to principle of least privileges. If we manage our IAM policies, like most of our customers do using Terraform, I can suddenly start to scan those policies and identify unused permissions or over permissive roles. The same for networking. I can look at things like my security group configurations or my Kubernetes cluster manifests and identify changes to my egress and egress policies that might reflect a potential over-permissive policy that might in turn be vulnerable and impact my infrastructure. And I think potentially where you can take this is take all this control plane intelligence from throughout the CI/CD pipeline and implement it into data plane. Today we see companies do this on their cloud provider by using things like their cloud native data protection tooling, things like encryption and DLP, and actually operate those tooling directly through infrastructure as code. So think of a centralized mechanism to prove and to ensure that data is secured from build time to runtime, that it's encrypted from build time to runtime, that it's audited from build time to runtime. So we're suddenly seeing this whole new world of opportunities that helps us adhere to our privacy and our regulatory controls around data protection. So I know this might be a little bit more than one-on-one, but I think the point is, and I think this is a huge revelation for us, seeing more and more companies adopt a modern CI/CD that's based on Terraform. Just so many opportunities to shift these manual, tedious, one-off security items and transition them into essentially codified and automated practices. We've looked at GitHub, and one of the things that I think is very interesting when we look at GitHub as a source for modules is the fact that so many users are leaning on existing projects, not only in infrastructure as code, but in many others, as their building blocks to essentially build out their infrastructure in the public cloud. We found, after looking at over 20,000 of the most used modules that are published to GitHub, that almost 1 in 2 did actually fail to comply to a standard best practice benchmark. And this obviously has a lot of sense, right? Because essentially think of Terraform and Terraform community as builders, essentially trying to build out something that's a functional set of modules that everybody can download and essentially use to build as a building block. No one expects the initial building block to really sustain the entire burden of keeping the end technology secure. And I think the lesson back to us as network operators, DevOps admins, etc., is that we have to be cautious that we have another point in the supply chain that we have to keep our eye on. As infrastructure as code becomes a more substantial building block in your array of technologies, you have to understand that the same way as you look at open source license contamination or potential image vulnerabilities and dependencies that I've mentioned, the validation and verification of composed and reused modules from infrastructure as code will essentially have a large impact on the posture of your environment. And we consider it as an educational challenge. We work internally with our developers. We work with our partners like Hashi. We work with some of the biggest cloud maintainers in Terraform registry and others to try to raise the awareness that people are, developers are essentially forking these libraries and taking them as is, and we essentially find them when we scan these configurations, essentially when we do that runtime scanning that I mentioned. So I think one of the best practices or lessons learned from this is really on how do we start to model infrastructure as code as the core, as a core focal point for configuration in our organization. And the benefits are pretty clear. So think about governance challenges in bigger environments. It becomes much easier to practice something like secure provisioning when we validate and verify our modules before they go into production. The same thing that we did 3 or 4 years ago when we just started having our artifact libraries and our image repositories as well. Yeah, as Kareem walks through the benefits, I will mention policy as code. I think I mentioned this before, but just to hold on that thought for one more second, it's not just the benefit of being able to analyze a consistent framework like Terraform that has its a consistent structure and very well defined rule sets on how it should operate and behave. The notion of policy as code, which Bridgecrew essentially um, um, translates in its policy engine, is the fact that suddenly everybody can be a part of affecting governance. If you think about how policies can be managed in something like your Azure deployment through a centralized Azure policies console, we view policy as code as a huge opportunity for development teams that want to adopt a stricter benchmark for quality of their infrastructure as code as a collaborative effort. And once policy becomes code and every coder has the permission or the rights to view the policies and to learn about it and actually to modify and change it based on their existing needs, I think that's a even a bigger opportunity for teams that are growing in infrastructure as code. Beautiful. So before we go into demo, I'd like to show you a quick example of a side project that we have and actually showed quite a lot of success. We call it TerraGoat. It's a completely open source project. And what it tries to do is essentially build a vulnerable by design Terraform environment. And the motivation for this was that infrastructure as code or infrastructure developers are not necessarily aware of how easy it is to miss a misconfiguration or how difficult it could be to detect it. So we really wanted to represent in a consistent project various types of misconfigurations we found in the wild. And this could be very straightforward things, but if you're following some of the latest news specifically around Kubernetes, you'll find interesting things that really can really hide in plain sight. So we took, for example, Azure Kubernetes Engine, one of the previous installations of the module that was publicly available, and it was interesting to find that generally was properly configured. You've probably heard the fact that if you leave your Kubernetes dashboard enabled, it could potentially be reachable through someone that has access to the pod. Obviously, using RBAC is a best practice, but you can eventually see it's 2 lines of code, a nested argument within, probably tens, if not hundreds, of optional arguments within your cluster's overall deployment. So if you took something like the off-the-shelf module for AKS, this is something that you can very easily have missed. And the idea for going on this project on TerraGoat was really to try to allow people that do this type of training and education to pay it forward and to show that even misconfigurations can hide in plain sight, and even with optional configurations not even highlighted, you can easily miss these opportunities to harden your infrastructure as code. So a few examples also for additional nested attributes that are not mandatory to deploy your AKS instance for the first time, and things you should probably have toggled on. Cool. Kareem, what do you think? Did I miss anything?
I think writing code is hard, and it's beautiful that with IAC, we're finally growing up to that stage where we're essentially solving the same problem that we solved for normal code, not infrastructure code, 10, 15 years ago, right? We're going back, revisiting, trying to figure out what's the ancestry of the thing I'm trying to deploy. Is my artifact safe? And what you're seeing right now, I mentioned this before, lots of scale out, lots of movement to the cloud, and security becomes almost an afterthought. It's as if our industry forgot all the good things we learned. Move fast, break things. It's sometimes too literal. Secrets get committed to version control. credentials don't get rotated often enough or don't get rotated at all. I think it's important to focus on the quality of engineering now more so than ever. I think, as you said, having compliance is a central part of that operation. You know, not a single person job, but as a whole team. That's where it really comes down to. If we all have skin in the game, it's a lot easier to fix it because I'm responsible for this. I feel responsible for this. And as a team effort, it's always going to be better. So I think, to me, any tool that makes it easy to have defense in depth, so multiple layers, is always good.
I definitely couldn't agree more, and we'll definitely touch on that multi-layer approach when we step into a demo. So maybe let's take 10 minutes and show you some of the inner works of what we do together between Terraform and Bridgecrew. In the meantime, we'd love to grab your questions. We left quite a lot of time for Q&A at the end, so please feel free to use the Q&A chat box. Let us know what you're thinking, and you know, we'd be happy to take any questions as we go forward. So I'll grab some presenter rights, and let me just set this up in terms of what we want to demonstrate today. So we built this setup to really show you a very classic, I call it the trifecta of most of the environment that we see. Probably, I would say 80% of our customers have either migrated to this setup or are continuously moving towards more and more setups that look like this. So multi-cloud's nice, but we definitely see AWS as probably the main cloud provider for large scale and medium-sized organizations. Definitely the one that enables, you know, the fastest deployment speed, the most wide array of technologies, and thankfully, I think the most robust provider in Terraform. So I think like almost complete coverage of all the exotic services, and definitely a lot of baked in best practices all the way down in the configuration languages in the HashiCorp language. So we have AWS deployed on the backend. We have GitHub as our version control. Definitely, you know, GitHub on our platform, first-class citizen. I think the same in Terraform Cloud. Native deployment in Bridgecrew through the authorization, the marketplace mechanism. But we've also invested the time to try to find various locations where our developers have found it useful to get insights about how and when they deploy code. So we chose GitHub as a place to do most of that work, because really, essentially, when you think of a process like code review and essentially your pull request, after that your commit process, that's where you want your team involved and to have maximal visibility into next steps of your deployment process. In this environment, we also have Terraform Cloud managing remote states and our deployment all the way down to AWS. So we have the Terraform Cloud operating here in the background. You see it actually automated as part of our pull request process. And you know, I don't have a lot of trust in the gods of a demo, especially on a webinar like this. That's why I have all these tabs open. But I will go on the limb here and try to actually commit one of the changes that I had prepared for today, actually a very simple Google Cloud bucket that I wanted to pull request and to see really if it can be pushed and deployed through my Terraform Cloud instance. So what I essentially did is took 8 files that define various Google Cloud configurations, and you can see through my native GitHub deployment, I have already 2 checks that are running on the background. I have a Bridgecrew GitHub action. I'll get to that in a sec. And I also have my Terraform Cloud instance that's going to start and kick off my plan phase and get that ready for the moment I'm ready to apply it. So you can see that that already passed. I have my Terraform plan passing without any conflicts. If you're not familiar with this, I can actually click this details button, go to my Terraform Cloud instance, and actually analyze the log, and to see that green text means everything's okay. I can definitely go ahead and apply my changes. Next, we have this Bridgecrew action that I mentioned, and this Bridgecrew action, essentially what it does, it runs a static code analysis, which has two interesting phases to it. So if you remember all of those small boxes that we had under the commit process and under the coding process, so these are a general abstraction of all of the types of potential issues or configurations that my code is going to try and to execute. And what's interesting is that sometimes these are these are things that I can fix even with 1 or 2 lines of code. And you can see that after about a minute running through all those use cases, from looking for secrets in access keys, which Kareem mentioned, to looking at all of the potential attributes that I did configure, the ones that I didn't configure, essentially we need someone that will automatically comb through those configurations. And what the GitHub action essentially does, it looks against all of those potential misconfiguration policies, and without me even having to define even one of them, I'm able to get the inputs of something that looks like it went wrong. So even though my Terraform cloud validated that I can definitely go ahead and apply this change, I can see my CI automation actually blocked it. And when I go into my GitHub action log, I don't, myself as a developer in this case, I don't really have to do anything else but review this log. So this is a standard JUnit XML with annotations to my code. I can see, for example, I have a few misconfigured attributes. For example, I have files in my code that misconfigured Dynamo point-in-time recovery. I can see my Google storage bucket didn't have encryption enabled, and I can definitely see in my resource that this attribute is missed. I can see next that my another bucket that I had defined later on down that file was misconfigured, and that I misconfigured my bucket level access. So all of these essentially get crunched into here, and from this point I have 2 options, right? I can actually annotate, decide these are accepted risks, skip them, and bypass the checks output, or I can go to my files and actually start remediating and adding the missing configurations, missing attributes, and start knocking off all of these checks. And this entire workflow had happened without, our developer at the back end having to go into Terraform Cloud to essentially go and individually check out if the plan moved forward without any hiccups, and without having to go to an external Bridgecrew cloud in this instance to check out what excuse me, what was the misconfigure that happened. So not only is this a completely synchronous process, but it's more about what is the context that we provided our developer before we asked them to start to try to handle some of these misconfigurations. So this is how it looks on the GitHub side. Let's take a look at how it looks on the Bridgecrew side. So Bridgecrew, I said it has 2 sides to the house. The deployment is actually pretty straightforward on build-time native integrations to all main VCS vendors through their marketplace integrations and centralized authorization. You can provide granular authorization to only the repositories that control infrastructure as code. And on the other side of the house, we tap into all 3 cloud providers. You can deploy us as a Terraform template that contains all of the resources, read access resources that are required to tap into configurations and to start evaluating them in real time. And from the moment you complete both sides of the integration, you can do just one, it's fine. But once you have both, you essentially give Bridgecrew the option to start building out this very robust graph representation of your infrastructure. So it's not only portraying what's the infrastructure that's currently deployed, but it's also taking into account all those feature branches and master branch that contain the potential configurations and potential infrastructure that's going to get into code, and uses that in order to enrich that initial point of view. And the goal of the Bridgecrew operator at this says, one is to start to set up the visibility. So one, let's start to see what assets, what resources do we currently have deployed in the public cloud, and start to evaluate them against known industry standards. And then if we pivot to the dashboard, we can start to check out what is our cloud footprint. And we have our posture dashboard essentially trying to tell you, hey, we're seeing this continuous growth in your cloud footprint, but on the other hand, we're seeing some minor areas where there's leaps in terms of misconfigured resources. And some of these could be pretty alarming. If we think about something like our public access into the internet, I could be alarmed by seeing that I have a 33% increase in the number of publicly accessible resources. These could be instances that are facing the internet that aren't supposed to, and maybe even a database that can be publicly accessible. Kareem, I see you're smiling there. Cool. So yeah,
it has definitely happened.
Okay.
It's hard, right? Like there's 3 main cloud providers. There's 50 other clouds, and you might be with a company that has their own private cloud. So now you need to know all the best practices for all those resources. Take just AWS. They have currently what, like 700 services, something like that. It's a lot. Even if it's just 100, it's impossible to know all of them.
Yeah.
I like tools that make that problem less of a problem.
Yeah. I like how Terraform lets me control that using the same programming language.
I'm with you on that.
Cool. So quickly stroll through this. I think what's most important about evaluating configurations is essentially you're not going to have the time as an individual to start to write the potential bad outcomes that configuration can have. And this is where we have your back. We've actually built a robust policy as code dictionary for all 3 cloud providers and also for Kubernetes. And all of these essentially apply those types of best practices automatically. And even before we start to block misconfigurations or to fail PRs, let's first run the existing infrastructure once and get a baseline view of what's currently going on. And this is where our out-of-the-box policies come into play. And these policies are essentially recommendations. So as an operator, you can decide, hey, this is something that I would like to manage on a case-by-case incident. And we actually enable users to manage the suppression for them and actually invoke a policy and disable it altogether. You can also write your custom policies. If you have your own tagging initiatives, if you want to restrict specific types of services, you can start by writing a policy all based on your existing infrastructure and actually get notified when those resources start to spin up. And you know, initially it becomes a place where the combined knowledge of how things should be and how things are all wound up in the same place. So we have a few policies already out of whack here. We can definitely take a look at all of them, but we don't really have the time. Let's take one with S3 buckets. You can see we have a variety of policies against all the bad things you can do with S3s. There's like a million ways you can screw up an S3 configuration if you're not doing it through the UI that now blocks it all. And that's definitely much more useful now, but definitely if you're using something like an infrastructure as code framework, if you're using serverless or CloudFormation or preferably Terraform, there's lots of ways you can screw up, and that's where our unified policies are very useful, because they won't only look at your Terraform code. They'll scan through any other infrastructure as code language that you have in your Git repo and essentially evaluate that against the best practice. And they won't only do that. They'll also provide the guidelines and remediation tactics to start to mitigate some of these issues. Let's take something quite lightweight like S3 access logging. So S3 access logging is essentially more intrusive, more granular, more detailed logging you can deploy for your S3 buckets. And we think it's highly recommended, specifically when you have buckets that contain potentially sensitive data. And you can see that when I essentially drilled into this use case, I saw I have multiple misconfigured entities. I have both running buckets already in production, and these are already deployed, but I also have the source control currently stored on GitHub and other places that's missing the versioning, the logging attribute. So Bridgecrew essentially offers to take care of both. You can either introduce a automated playbook that will go into that S3 bucket and remediate it, but you can also push a fix pull request into your GitLab or GitHub that will contain the fix. So really wanted to demonstrate both of those today. Won't really have the time because we do have only 10 minutes. So really, we wanted to extend the invitation. The platform has actually a free tier up to 100 resource. So your infrastructure as code library, you're probably not aware of it, but probably doesn't have more than that 100 resources. If it does, it's also okay. You can sign up for the platform for free, no credit card required, and get your first scan and to see some of the fixes off the bat. There's actually no limit initially to the number of fixes or playbooks you can invoke. So you can use it to both get the initial visibility and to start to take a stab at some of those preventive controls that I showed you along the way. And that's, we'll have to stop here, unfortunately, just to leave some time for Q&A. Peyton, what do you think?
Yeah, that was great. If anybody has questions, feel free to ask them in the Q&A panel. We have a couple coming in. Maybe one.
So before we get into questions, I just want to say that pre-built policies are very nice, right? Like you maintain them for me, which means I can hit the ground running rather than just hitting the ground, which is very much what I like.
Love it. Yeah, you're right.
Oh, we did have one other slide too. If you want to show that, Kareem.
Absolutely.
Just some links for you all. I'll drop them here in the channel too. We do have a pretty in-depth tutorial as well on the Bridgecrew blog. It walks you through getting started with GitHub Actions for Terraform scanning. It's pretty helpful. And yeah, as Guy mentioned, feel free to check out the Bridgecrew platform. We do have that free tier. Deborah, yes, this recording will be available probably this afternoon. I have one question for you, Kareem. What are the potential long-term gains of implementing IAC?
So in just a few words, the best and biggest gain you can get from IAC is peace of mind. You can look at your code, you can easily test it, you can talk about it with your colleagues before you even spin up the first instance, before you cause any misconfiguration. And because it's code, you can have static code analysis like we saw. You can duplicate it in the sense that you need 100 resources. Awesome, just change this one variable that says 1 and change it to 100. Now you have 100 of these virtual machines. It's very easy to edit text, and it's a lot harder to go into a cloud provider console and click around and make sure you always click the same things. Humans are lazy, and clicking around generally introduces more errors than editing your text. And that would be why I think IAC makes sense.
Cool. A question for you, Guy. I know that you have some open source projects / tools. You mentioned one TerraGoat. How do Chekhov and AirIM tie into the Bridgecrew platform as a whole?
Oh, great question. So we actually have quite a few projects, all open source, all under the Apache 2 license, available at the Bridgecrew.io GitHub library. Chekhov, probably the most famous of them all. Chekhov is essentially that layer of static code analysis that can be run as either a one-off or a continuous scan for most configuration frameworks. It abandons some very powerful community contributed policies. Essentially, some of those policies eventually get boiled into our core platform. It does have its limitations in terms of eventually creating the complete graph and variable rendering. But if you want to start testing locally your infrastructure as code, your Terraform files, definitely a great place for beginners to start. You should be aware of some of the limitations in terms of in-depth analysis. Next is TerraCode that I had mentioned. It's our learning open source. It contains all the learning assets vulnerable by design Terraform templates for Google Cloud, Azure, and AWS. So you can actually take TerraCode, scan it using your locally installed or your continuously installed Chekhov instance. And last one is RAM, which is one of our most exciting projects. It's a kind of a forward-thinking project. What it essentially tries to do is to help companies that currently have IAM meshed together, managed in runtime, and actually to terraform it into a very compact, least privilege, standardized Terraform file. So it's a command line tool. It's super straightforward. It starts by scanning your existing IAM documents and policies in AWS, creates that model, and removes unused resources, and keeps only the instances of IAM entities that are actually in use, and it actually populates them into a compact set of groups and roles, and really tries to adhere to that holy grail of least privileges. So definitely try to give that a look. It will not push any entities back into your code. You'll have to go to Terraform Cloud and implement it through there, but it's definitely a good way to get started with getting your IAM into a consistent data pattern.
Cool. Looks like no more questions from attendees and folks are dropping off, but I have one that I'd like to ask. Final words of advice for people just getting started with IAC in general and IAC security.
I'll go first. I think no matter where your attack comes from, no matter if it's intentional or not, you have access to a ton of tooling that you can use to harden your code, right? You can run stuff locally. You can run it in the cloud. You can have it as part of your GitHub actions, pre-commits. Layers and layers usually are bad in terms of management, but they're great when you're hardening your code.
Mm-hmm.
So make sure you just have a lot of this stuff set up properly. Invest that time when you're starting out, and then reuse that for multiple repositories.
Completely agree. I would say experiment responsibly. There's a lot of great resources online on how to get started with Terraform and securing Terraform as well. There's actually amazing open source tooling already to help you verify, validate, clean your Terraform code. I would say that as you progress and get more infrastructure into your public cloud, be continuously conscious of that supply chain of modules and potential composition that's done on top of them, and try to find good ways to automate your testing and your continuous testing.
Cool. Cool. Well, thanks, Kareem and Guy. Thanks for everybody who joined, and look out for the recording and slides after this. Have a good one.
Thank you.
Bye, Peyton. Bye, Kareem.
Bye.
Bye.